Okay, so now that we've tackled a lot of the methods that we're going to be using and a little bit about how we want to think about our mover orientation, we can tackle this and make a mover rotate around. And it's kind of, we're just making the orientation plane rotate around, and that orientation plane is what we're going to describe our mover orientation. So first off, I just brought in a bunch of stuff from our other videos, and I updated Grasshopper, so that's why there's old on those. I'm not going to worry about that right now. This basic setup is what we've had before. Our pi list is what we've had before. Our counter is what we've had before. I have a point over here and a point up here. And so now I want to bring in our oscillation. So I have our rotation methods, and I'm going to copy and paste that. And what I really want out of this is I just want to copy. I'm going to actually copy import Rhino script syntax while I'm at it, just so I don't have to do that as well. Okay, so now that we have that, I'm going to bring a Python. I'm going to paste that in, and we're going to create a mover. So it's going to be a class mover, and we're going to call it mover orientation because we're going to be discussing orientation. And we're not going to actually have it move, so I guess you could say non-mover mover. So def init, and we're just having the basics, so self, and we want to initialize the self orientation plane as the RS world x-axis, world xy plane. Sorry, x-axis, that doesn't make sense. So now we need to discuss, we want to have some, like I said in the last video, of an orientating vector, and so we can do that by, we're going to have a point is going to give us the information to make that. So we've got the point there. Let's bring the point in. So this vector is going to be our rotation, our orientating vector for rotation. So we need to bring that in, and like we did with our other ones, we have time. We're going to have a time component to it. And then, so we need orientation vector for rotation. Okay, so now that we have that, and I guess we didn't need to do it in that order because we are going to have an orient method, and what we're going to pass into that method is an orientation vector that we're going to call orientation vector rotate because it's going to describe that rotation. And so like I said in the last video, we're going to remap this onto whatever our we're going to remap this vector onto whatever our orientation plane is. So remap point, which is one of the ones that we brought in, So vector, reference plane, target plane. So the vector is the OV rotation that we're passing in. Our reference plane is the RS world XY plane. Our target vector is self OP. So that's going to give us a remapped point, and we're just going to say RMP for remapped point. And now we want to rotate our plane to that vector that we have mapped. So we're going to give it a new orientation plane, and so rotate plane to vec, and look up and see rotate plane to vec, pass in a plane and a vector, and rotates a plane so that the z-axis mirrors vec. Okay, so plane and vector. The plane is OP and the vector is our remapped point. So that's going to update this based on that when we call it. So that's all we need for this particular mover. So let's create the mover. Well, no, let's do our time list. So time list, we have an empty list for t in range time. This is, I mean, we've done this a few times before. And then we have this moment equals something something inside that list, and then we t list dot append this moment a equals t list. Okay, so we're going to do something in there. That's our basic time setup that we've done. So now we want to create our mover, and we're going to say m equals mover orientation. And so now that we have the mover, we can say m dot orient, and we're going to pass in the OV rotation. So let's try this, see if there's any bugs. Mover orientation is not defined. Line 60. Sorry, that's really basic. Okay, got a float, so we need to set this up as an int, set our time up as an integer, and we're getting information out. So also I forgot to put something in our this moment, and what we're going to pass in is m.op. So we're going to be passing out a plane. Okay, so let's test this and see if it works. So you can see that it is working, and maybe it'll be more clear if I do plane. Yeah, plane, deconstruct plane, and have Z and have a sphere, and multiplication, and we're going to scale it by something. Okay, so you can see there now that it's rotating around and it's going by this. So if we move this over, you can see that it's rotating quite a bit faster, slower, 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 and what I like about having it set up this way is that we can position it wherever we want and it will rotate that way. So this gives us the basic setup, and now we can deal with rotation speed.